Okay, folks, so this is the second video which talks us through a bit more of the theory about why it is very warm at the equator as opposed to the North or South Pole. A very simple way to look at that is just through a diagram. We'll look at three main things. Now, what you'll notice here is right here, in this little space where I've drawn the little funny star, that's where I'm going to get you to write down some notes in a minute or two. But I'm going to talk it through first of all. So I'm going to add some annotation. You can do the same in terms of the arrows, but I really want you to leave this space blank because I'll get you to write down some notes that I've just prepared in advance of this. So for this, then we have to think about a number of things. And the first one I'm going to call is the angle of incidence, or the angle the sun's energy approaches the Earth. So I'm going to show this with an arrow. And if you live at the equator, the sun's energy approaches like that. If you live towards the North Pole, you can just about see that the Earth's a bit more curved, but it still approaches straight. Now, those hours are the same currently, but it'll change a little bit because whenever the sun's energy approaches at this point, you'll find that it's going to be more readily deflected away because of the angle. Whereas here, it's going to come down and it's going to be, I suppose, a bit more flat, and it's not going to be readily scattered away left or right. It tends to come down like a bouncing ball will come down on the surface and bounce back up again, as opposed to bouncing away quickly. So that actually has an impact on the intensity of the sun. And that means that as the sun's energy is approaching this area here, it means it's slightly warmer as opposed to approaching and then shooting off. And that's called angle of incidence, or the angle of the sun's energy. Okay, so you can draw those arrows on if you wish. Okay. Now, the second reason I've taken the arrows away just for the purpose of this. The second reason is about how concentrated the sun's energy is. And if you looked at this very carefully, you can just about see that from there to there is clearly much shorter than from there to there, even though these 2 points are the same. Because the way the globe curves, it actually gives you a longer space or longer distance between those 2 points. So there's a greater area. And that refers to the concentration of the sun's energy. So the sun's energy is still approached with the arrow, but it's actually concentrated on this little part as opposed to being concentrated on this larger part. And sometimes I represent that by saying how that is point A, that is point B, that's point C, and that's point D. So the distance from A to B is actually much greater than the distance from C to D. And because of that, then the energy is much more concentrated. So the word we're looking for there is concentration. It's much more concentrated at this point. And then the final bit you'll notice here is to do with the thickness of the atmosphere. And again, this is due to the curvature. And you'll see here to there, because the way the globe curves away, this distance from there to there appears to be much thicker. Now the atmosphere itself isn't thicker, there's just more of it because of the way the globe curves away. So as the sun's energy passes through the atmosphere here and there, it'll actually pass through more atmosphere than it would at this point. And as a result of that, whenever it passes through the atmosphere, it's then reflected away, it's scattered, it's basically filtered. So the sun's energy is filtered somewhat. And that means that less of it reaches the Earth's surface. Now, as a result of that, you'll find that this location here will be much warmer because the sun is coming straight, because it's passing through less atmosphere, and because it's concentrated on a smaller space, as opposed to here, because it's being reflected or deflected, it passes through more atmosphere and it's spread over a longer space of time. Now, that's a very quick run through. The notes in this little location here will appear on the next slide. I would like you to pause and then type those out, please, or write those down. There you go.